Howdy. Welcome to Code Space. Basically, the idea with Code Space is to just assist in the capacitation of the general populace, for lack of a better term, to improve their coding, to build and improve their coding skills. It's the new currency in today's knowledge economy. You talk about artificial intelligence, talk about innovation, talk about machine learning, but fundamentally, for you to get to optimize, to use those concepts in an optimal manner, it's important to have the fundamental building blocks. And one of the building blocks in terms of just understanding systems is databases. So databases are pretty much uh, pretty much omnipresent. They are literally present in every application that you see. So the introduction to databases seeks to equip those without any form of knowledge in terms of ICTs to just understand the underlying concept, the concept that then data becomes, that then all things that are happening in terms of data are built upon. And there's this adage now which says data is the new oil. So delving into the introduction to databases, moving on to the next. So what is a database? So basically, a database is a structured collection of data in so previously, if it was not electronic systems, they would still refer to it as some form of a database where you have your a structure around storage of files. But now within the context of electronic system, it then assists us to effectively store information in an efficient manner, organizes large amounts of data. It also enables the fast retrieval, modification, and management of data. And also, most of the modern databases they allow multiple users and applications. So these then become the fundamental building blocks in terms of management of information within the internet, within our computer systems. This becomes the platform. When we talk about artificial intelligence, when we talk about machine learning, initially it all comes from data, and data which is stored in databases. What is the importance of databases, and what are the essentials that a database should have in terms of a modern database? You're looking at data integrity, you're looking at data accuracy, but there must also be security and access control, which means that the data that sits in a database, it must not be accessed literally by everyone. You must have the different access controls that exist so that relevant people can access data that is relevant to them. Look at it from a practical perspective. Imagine if there was no concept of security or access control. You go into a database or into a system, a banking system, you can be able, without that component of access control, you can be able to access even other people's accounts and make transfers. So the concept of security, the concept of access control becomes pertinent when you're looking at it from a practical perspective. And then you talk about scalability. Scalability refers to the ability of the system to grow. So imagine now you're starting off your company. Maybe initially when you start, you've got 5 clients, but now then the company gets to grow. You have 1 million clients making, let's say it's a mobile network operator. You're making calls every minute. All that information must be recorded. So the system should have the ability to scale, to grow, but as it grows, the performance should remain the same. There must be optimal performance as you grow. And also now you're looking at delving into other components that are critical is a database must have a backup and a corresponding recovery mechanism. So would say in any scenario, systems are not immune, for example, to hacking or just a system crash. You must have in place methodologies that will assist you to be able to one backup that data. So generally, you could even be backing up having an automatic daily backup of the database so that in the event that something gets to happen, you can quickly recover the data without much loss. And I think we delved into supporting of multiple users, but at different levels. That's sort of the essence of a modern database. And in terms of examples you're looking at, I think the most critical in our context then becomes all our banking systems, whether you are accessing it through your USSD via a mobile app, or even the web. It's just sitting premised on a database, but also there are your e-commerce sites. It's basically based on all the activities, all the shopping carts, all the buying, all the credits that you get is premised on data which will be persisted and stored in a database. And you look at also as social media sites, it's based on database, different type of databases, but all those social media sites is based on database. And also healthcare, when you go to the pharmacy and probably they want to confirm whether your medical aid is going to be able to pay for whatever you seek to you seek to purchase. That whole interaction between these two systems, it's one database querying the other database. Obviously there are mechanism when then people talk about APIs and everything, but fundamentally at the core it is the interaction of databases. And then now when we go into what are the types of databases that exist. So the most common type of databases are relational databases. And I think whenever you hear relational databases, and they've got structured tables based on structured query language, which is SQL. You have your Microsoft SQL. You have got your MySQL. You have got your Postgres SQL. These are the relational databases. And then you have also relatively newer types. Okay, not so new now, but you've got your NoSQL databases, which are sort of which are flexible. They're schemaless. You've got your Cassandra database. You've got your MongoDB, and so basically, uh, and this is I think something that's very critical. Is somebody what I've interacting with colleagues as people have been trying to research around just how do you start getting into the world of technology. I think some of these terms you've just been hearing them as you Google around, or as you are doing your research. And I honestly believe that this is just a teaser, and it's just important that as you just hear some of these terms, you can do further research. But what we would want to do is assist each other, guide each other, just to go into the process slow, but one step at a time. And then you also have got your object oriented databases, which get to store to store the data as objects, but also you have other specialized databases, especially as, for example, your time series InfluxDB, your graph based and your cloud based query BigQuery. So those are also databases that are contextual. Some of them are very good when you look at recording of real time data and related stuff. So these are sort of the types of database. Obviously, we will later in advanced topics delve into each related one, but that sort of gives you a high level summary in terms of the types of databases that exist. And then obviously delving into the relational databases, they store, I think this is basically, if you've dealt with even your good old Excel where you've got rows and columns, it's just that whole concept of relational database. So data is stored in tables which are comprised of rows and columns. It uses query language for querying and data management. It supports relations between various tables, and also it follows the asset properties for reliability. We will delve into this at a later stage. So the examples, I think, as mentioned earlier, you've got your MySQL, your Postgres, your SQL Server, your Oracle database, and then going into the NoSQL database. It's designed for unstructured or semi-structured data, very scalable and flexible. It's used in big data, real-time applications. Some of the time, depending on the quantum of data, some of the times certain applications they actually persist initially and in a relational database, and then they push or do some form of archiving from into Mongo into this NoSQL, especially when it's now relates to large amounts of data. So you look at the types. You've got your document based, which is for like your MongoDB, and then key value, your DynamoDB, column based, your Cassandra, and also then delving into your Neo4j. So basically, that's from a NoSQL database perspective. So then going into object-oriented databases, it stores data based on object-oriented principles. So just the way your Java, just the way your C Sharp just does that management of data from an info in management like the principles that are behind your Java, that are behind your C Sharp. It's also the same concept that object oriented databases are managed. It obviously supports the main items that your inheritance, your encapsulation, your polymorphization. I think these are topics that we'll delve into at a later stage. So you've got your object DB. Those are some of the examples of object-oriented databases. Then there is now, for each and every database, you then have your database management system. So for example, I think you've seen your SQL management studio. Those then becomes your database management system. A database management system is a software that enables users to store, retrieve, and manage data in an effective manner. So the database will be sitting at the back. This then furnishes you with a user interface to assist you to do transactions in the database. So it assists you with the data storage, retrieval, even access control and security, backing up. You can use it for backing up, and then the subsequent recovery.